Hello all, good day. My name is Tejas Sai Kumar Medicharla. I'm going to discuss about paper reading topic. My topic is introducing activation atlases. Agenda: abstract, introduction, motivation, significance, paper methodology, architecture, paper proposal, strengths, limitations, and conclusion. Abstract: activation atlases, which display intricate activation patterns in a clear, low-dimensional space, provide previous unobtainable insight into the neural network's decision-making process. This abstract advances the search for interpretability and transparency in artificial intelligence by examining their approach, experimental result, and consequences. It also sheds light on black box aspect of neural networks. Introduction: Activational Atlases offers a fresh perspective on comprehending the underlying working of brain networks. They offer representations of high dimensional activation patterns in a low dimensional space that is easier to understand. This introduction provides context for examining the activation atlases technique, importance, and advantages. An innovation an innovative way to comprehend neural networks is through activation atlases. They represent low dimensional activation patterns that are high dimensional in a more comprehensible manner. Motivation: regarding their decision making process, traditional neural network frequent functions as black boxes, making comprehension difficult. With their comprehensible representation that illuminate the fundamental working of brain networks, activational atlases seems to be a viable solution. Trust and adaptation of machine learning models are largely dependent on interoperability, particularly in vital industries like finance and healthcare. Enhancing neural network models' interoperability and making them easier to use in a practical applications are to benefit the activation atlases can offer. Significance: an innovative method for disapprehends the behavior of neural networks is provided by activation atlases. They offer comprehensible illustrations of interact activation patterns, boost comprehension and confidence in neural network predictions, facilitate a more profound understanding of decision making processes within models. Paper methodology. Methodology overview. Activation atlases are provided by projecting neuron high dimensional activation patterns in a low dimensional environment that is easier to understand. The process entails taking activation of our neural networks, various layers, and projecting them onto a 2D or 3D spaces. Principal component analysis. PCA and T distributed stochastic embedding T-NSC SNE are two methods that can be used to reduce dimensionality. Architecture: visualizing the patterns of neuronal activation at various neural networks layer yield activation atlases. After that, these activations are projected into a low dimensional space using methods such as T-distributed sophisticated neighbor embedded TSNE or principal component analysis PCA. The interoperability and confidence in these models are improved by this architectural style, which gives researchers important new insights into how neural networks process information and generate predictions. Paper proposal: visualizing the simulation patterns of the neural neurons at various neural network layer yields activation atlases. By visualizing patterns of neuronal simulations, neural network models become more interpretable and trustworthy, with potential implications in various fields including robotics, economics, healthcare. The study seeks to further our understanding of neural network activity. Project high dimensional activation vectors into low dimensional area using methods such as PCA and TSNE. Experimental setup 1. Aggregating multiple images. Comprehend network responses to millions of photos by combining activations. Gather a single spatial activation from every picture to produce a million activation vectors. For dimensionality reduction, apply contemporary methods like as TSNE and UMAP. Over the 2D layout, the dimensional reductions produces dry grid. To produce a memorable image, the average activations within a grid cell. Result 1. Aggregations and grouping of activations for 1 million photos successfully completed. Activation vectors with high dimensions are arranged to through using of two methods TSNS UMAP. The meaningful representations and interpretations of activations was made possibility by a grid-based aggregations. Experimental setup 2. Looking at a single image. Pay attention to inception V1 neural networks which gained theoretically after taking down to 2001 images net competitions. Examine the inception V1 layers, mixed 3A, mixed 3B and so forth. This experiment has done after this taking into our account assessment the some neurons on each every path the preceding layers for a more thorough examinations. Result of this is visualization of various layers of at which inception V1 interprets individual images is successful, and analyzing several layers made it possible to grasp the inception V1 imaging processing. Here we got image input, image path, activation, feature visualization, and activation grid. And experimental setup 3, looking at multiple layers to comprehend the evolution of abstractions, concentrate on examining the neural network several layers. Numerous layers make up conventional networks which gradually construct abstractions with great power. They are three layers: initial layer, mixed 3B, intermediate layer, mixed 4C, and last layer before logic is mixed 5B. The regions that to go classify cabbage into each layer are examined. Result 3. The result 3 was presented here: mixed 3B, mixed 4C, and mixed 5B. These are the representations of mixed 3B, mixed 4C, mixed 5B, mixed 4C, and mixed 5B. Strength. Deep knowledge. Activation atlases shed light on a network activity throughout layers and the data. Historical visualization. To help understand the model, activation atlases show the progress of features. And the strengths are effective aggregation, interpretability boost, etc. Limitations. We have limitations like scalability issues, architecture dependency, interpretation complexity, representation bias. Here we are coming with the conclusion. Activation atlases revolve neural networks understanding. They offers easily understood representation of neural network activations. The tools dispensing a choice and activation is the activation atlas. The model interface transparency are improved by the introduction. A deep understanding of neural network operation is made by activation atlases. And in this, I'm discussing mainly this conclusion about a deep understanding of neural network operation is made possible by activation atlases. Thank you so much. Have a good day for all.